section 1 of chapter 8 starts off with linear motion problems. So those are the velocity problems, given a position function, find the distance traveled, find displacement. It's the type of problems that the physics students are able to relate to the most, but that doesn't mean that the rest of you guys can't. And you're going to have to for the AP test. So I'm going to start off by going over a few examples straight from the textbook. So if you want to follow along, it's on page 385. And I'm going to start off with example 1, which reads, figure 8.1 shows the velocity ds over dt is equal to v of t, which is equal to t squared minus 8 over t plus 1 squared, and it's given in centimeters per second. And this is the velocity of a particle moving along a horizontal s-axis for time, which is in the interval from 0 to 5. You are asked to describe the motion. So one thing that I want to point out is that we are talking about a derivative. So quick reminder that if we're given a position function, let's say y equals s of t, then we know that velocity, let's say v of t, is the derivative of that position function, so it's s prime of t. And a of t, acceleration, is the first derivative of velocity, or in other words, that's the comparison of the second derivative of the position function. So what we have here is the derivative of a position function, and pretty much what we have when we graph this function is going to be the graph of a derivative. And I'm going to graph it because if you are following along, you'll see that they're expecting you to describe the motion, but they give you the graph. So you're supposed to be describing the motion based on the graph that's given to you, that's provided to you. Okay? But one thing that we can do is we can figure out what the velocity is when t is equal to 0. So, kind of some stuff to put aside, but we can do this without the graph. So when t is equal to 0, we pretty much have v of 0 is equal to 0 squared minus 8 over 0 plus 1 squared. Well, this is just negative 8. So because it's negative, we know that this specific particle has an initial velocity that is 8 centimeters per second, but it's moving to the left. So this is coming straight from your textbook, but we know that it's to the left because of that negative sign that came out in front of the 8. And to explain the rest, I'm going to go ahead and use the graphing calculator here. If you want to follow along and graph this, I obviously go to y equals and just type in the function. Instead of t's, I just put x's, and it still graphs the exact same function that you see on your in your textbook, and it kind of reassures that we do start at 0, negative 8. Now, one thing that I want you to notice about this graph is that So obviously if my graph is down here below the x-axis, then it's in the negative position. You guys know that. But if we want to apply this to the problem, this tells us that velocity up to this intercept here, up to this x axis there, we have a velocity that's less than 0, that's negative. And then after that, we pretty much have it positive. Again, this shouldn't be new to you. Now we have velocity that's greater than 0, positive. Now what I want you to look at is, I want you to look at the slope. So let's look at the slope of this velocity, the graph of this velocity function. And if you notice, I'm just picking random places. The slope is positive throughout. Okay, so if we're talking about the slope of the velocity, I just brought this up earlier, we're talking about acceleration. Because we're talking about the slope of velocity, that's the same thing as the derivative of velocity. So if the derivative of the velocity is positive all throughout, then a of t, acceleration, is positive all throughout. And I bring this up for a reason. I want you to add this to your notes. So if velocity is positive and acceleration is positive, you are speeding up. If velocity is negative and acceleration is also negative, you are still speeding up. Okay, so in other words, speed is increasing. If velocity is positive, however, acceleration is negative, you are slowing down, and that applies also if velocity is negative, yet acceleration is positive. So you're slowing down or speed is decreasing. In other words, if the sign of velocity and acceleration are the same, you are speeding up. If the sign of velocity and acceleration are different, you are slowing down. This is why your textbook for the solution says that the particle slows to a halt at about t is equal to 1.25 seconds, after which it moves to the right where velocity is positive with increasing speed, reaching a velocity of v of 5 is approximately 24.8 centimeters per second at the end. So where did 1.25, t is equal to 1.25 come from? That's here. And if we want to find it, if we actually want to calculate, go to second, trace, so that you go to the calculate, hit intersect. 5. Oh, we can't find the intersect yet. So scratch that. Before we do that, we need to type in type in the second equation of y equals 0. So y equals 0 runs along the x-axis. Now we can calculate an intersection. Go ahead and hit enter for the first curve, hit enter for the second curve, and have it guess it. And there is your intersection of 1.2545447. Your textbook does say approximately, or it says at about 1.25. That's because this is the exact value. Alright, so hopefully that helped you understand example 1. Example 2 is on page 386. Suppose the initial position of the particle in example 1 is s of 0 is equal to 9. What is the particle's position at A? T is equal to 1 second. So add this to your notes. When you integrate velocity with respect to time, you are given position or displacement. It's important to know this because the textbook right away gets into the displacement is equal to the integral from 0 to 1 of v of t dt. Or in other words, it's the integral from 0 to 1 of t squared minus 8 over t plus 1 quantity squared dt, because this is what's given for velocity. Okay, so I'm going to start showing you guys how to use a graphing calculator to integrate. So go to Math, number 9. So Math 9 takes you to the integral. So we're going to go the integral from 0 to 1. And just like when I graphed it, I'm not going to put t's, I'm going to put x. So x squared, the function is x squared minus, now I'm going to get the fraction by going to alpha 1 or alpha y equals and then 1, and now I have the fraction 8 over quantity t plus 1 or x plus 1, I don't have t's, squared. And since I decided to use x's instead of t's, I'm going to go ahead and put d of x or dx with respect to x. I'm going to hit enter. Okay, so your textbook leaves it as negative 11 over 3, and I just want to show you that they are the same thing. Negative 3.66666666, and it keeps on going. But I rather you keep it as fractions. So using our calculator, we were very easily able to calculate this to negative 11 over 3. But that's not the answer, and you can see that the answer is showing 16 over 3, and that is because we can't forget that initial condition, or that starting position, so that we have to add 9 to that. So in other words, s of 0 plus the integral from 0 to 1 of v of t dt is what's going to give us the final answer. So 9 plus negative 11 over 3 is what gives us the final answer. Okay, so I'm going to try to quickly go through example 3. I'm going to try to squeeze this in real quick. It's talking about distance. Find the distance traveled for example 1. So add this to your notes. Integrating speed will give you a distance, but if you remember, a few months ago I told you speed is the absolute value of velocity. So if speed is the absolute value of velocity, then integrating the absolute value of velocity will give you the distance. This is why your textbook pretty much gives you this. The total distance traveled is this. So I'm going to use the graphing calculator to get this answer. So go to Math 9 to get to the integral. We're going to go from 0 to 5. And to get to the absolute value bars, go to Math, go to the right to NUM and number 1 ABS, and go ahead and type in the function. You should get something like this once you type it in, and you hit enter. And there is the answer that you see in your textbook. So after all that, you see that we get 42.586. Remember, 3 places. Your textbook did not do that, but for the AP test, you do have to do 3 places. Truncate, I truncated. And notice that your textbook has this notation. This is the notation for those of you guys that have a graphing calculator at home that's not updated. This is how you would input it if you see NINT when you hit Math 9. Okay, so keep this in mind. And I know that was a lot on this video, a lot to take in, but I think this is very helpful, especially for the AP test. But that is it.